Welcome sa ating first lecture dito sa Geotechnical Engineering 1, which is the soil mechanics. And ang outline ng video na to is discussion and derivation of the formula. And syempre, problem solving para ma-appreciate nyo naman yung mga formula na i-discuss. So, ang objective natin dito is syempre dapat ma-familiarize kayo dun sa mga equation, especially sa paggamit ng mga equation na yon pagdating sa field and sa laboratory. So without any further ado, let's start by discussing the soil composition first. So basically, ang soil ay meron siyang iba't ibang components like the minerals, organic matter, it also contains water and air. But the organic matter and the minerals, pwede natin siyang i-generalize as the solids. In a general sense, tatlo lang ang composition ng soil natin. So we have the soil solids na maaring minerals nga or organic matter. We have the water and the air. So itong mga components na to ang gagamitin natin to establish different relations to come up with some powerful equation na maaari nating magamit sa field or sa laboratory. So kung makikita ninyo dito sa ating illustration, meron tayo ditong soil solids. Ito yung mga solid particles. And we have the pore water. So ito yung mga tubig within the void spaces. So kasi may mga void spaces yan sa pagitan ng mga soil solids. So maaaring malagyan siya ng tubig or yung ibang part ng voids ay air lang. So that is the air pocket. Kung titingnan natin yung mismong soil mass, mukhang mahihirapan tayong i-analyze ito kung yung mismong actual structure ng soil yung gagamitin natin. So, para sa analysis ng soil, gumagamit tayo ng tinatawag na block diagram or phase diagram na kung saan pinaghihiwa-hiwalay na natin yung mga composition or components of soil. So, we have air sa taas dahil mas magaan or yung density ng air is mas mababa compare sa dalawa pa nating components. Water, nasa pagitan siya dahil mas mataas naman yung kanyang density compare sa air pero mababa yun compare sa solid. Kaya yung solids natin ay nasa pinakailalim dahil mataas ang kanyang density. So ito yung tinatawag natin na phase diagram. And under this condition na kung saan meron kang air, water, and solids doon sa iyong soil mass, ang tawag natin sa ating lupa is normal condition. So, there are different conditions of soil. Like for example na yung void spaces natin ay filled with water. So kung saan walang air pockets doon sa mismong soil mass natin. Ang tawag natin sa condition ng soil na yan is the saturated condition. So dalawa lang yung makikita mong components. We have the water and the soil solids. Pwede rin naman na mangyari is yung void spaces natin ay air lang. So, walang existence of water. So, ang tawag naman natin dito is the dry condition of the soil. But, mag-focus muna tayo doon sa normal condition of the soil and then i-adjust na lang natin mamaya yung makakuha nating relation kapag naging saturated na siya at naging dry condition. So, doon tayo sa general. We have the normal condition of the soil. So, ang gagawin natin dito sa phase diagram is lalagyan natin to ng dimension. So, ang dimension is not with respect to the thickness, but first, with respect to the volume muna tayo. So, ang una nating lalagay is we have here the volume of the air voids. So, we designate it as V sub A. And then, para naman sa water, syempre, ang gagawin nating designation is V sub W or the volume of the pore water. And para naman sa solids, we have V sub S, that is the volume of the soil solids. So kung mapapansin natin na yung sum ng air, volume of the air and the volume of the water, ang ibibigay sa atin yan ay volume of the voids. So yun yung total volume of the voids. So maaaring yung volume of the voids ay magiging volume lang ng water kapag saturated or volume lang ng air kapag dry. Kapag sinamap natin itong mga volumes na to, syempre, magka-come up tayo with the total volume of the soil. By expression, that is, the volume of the voids plus the volume of the soil solids is equal to the total volume of the soil, where the volume of the voids could either be the sum of the air, the volume of the air and the water, or air alone or water alone. So it depends on the condition of the soil. But for the normal condition, the volume of the voids is the sum of the two components, air and water. So kung magiging saturated man yung lupa natin, so yung magiging volume of the voids natin dito is equal to the volume of the water. Pero same pa rin naman yung magiging formula natin sa pag-compute ng total volume of the soil. Still, volume of the voids plus volume of the soil solids, nagbabago lang naman yung volume of the voids natin depende sa condition. So kung sakali man na yung soil natin is under dry condition, so yung volume of the voids natin ay magiging volume of the air lang. And same pa rin tayo ng formula para sa total volume of the soil. So yan yung mga basic formula na gagamitin natin later on sa pag-establish ng mga relation and mga properties of soil. And now, let's proceed to the volumetric ratio. So, ito na yung mga properties na kailangan nating tandaan para sa pag-derive ng equation. So, ito yung mga basic ratios lang muna. So, umpisahan natin sa void ratio. So, ang designation natin ng void ratio is E. And the void ratio is the ratio of the volume of the voids to the volume of the soil solids. By expression, that is E equals to VV over VS. So, napakasimple lang ng equation kasi ratio lang naman to ng mga volumes na meron tayo. Pero, kunin natin muna kung hanggang saan ba yung boundary ng ating void ratio. Gaano ba kababa yung pinakamababang value niya at gaano kataas yung pinakamataas na value niya. So, gawin natin yung mga boundaries. So, syempre mag-a-assume ka muna ng mga condition or ng mga relation between the volume of the void to the volume of the soil solids and identify mo if possible ba na mangyari iyon. If possible, then pwede ka na mag-start mag-analyze doon sa relation na ginawa mo. So when we talk about the volume of the voids within the soil mass, lagi niyong tatandaan na hindi ito pwedeng maging zero. Never na mangyayari na yung volume of the voids of a soil ay zero. Ibig sabihin, walang air, walang water, puro solids lang, and that is impossible. Siguro kahit anong gawin mong compaction method, ay hindi mo magagawang zero yung volume of the void. Siguro kaya nating i-minimize yung value, but not to the point na maging zero yung value ng volume of the void. So, if the volume of the void cannot be zero, cannot be equal to zero, kung titingnan natin yung equation na VV over VS, then therefore E must not be equal to 0. So, kumbaga, nakita na natin yung kanyang limit, lower limit, na bawal siyang maging 0, pero any value greater than 0 is possible. So, how about if we assume that the volume of the soil solids is greater than the volume of the voids? Is that possible? Tingnan natin. So, kung maggagawa ako ng block diagram or phase diagram, posibleng mangyari na yung volume of the soil solids natin ay mas malaki kaysa sa volume of the voids. As long as nandyan yung voids, okay lang yan dahil sabi ko nga kanina, volume of the voids must not be equal to 0, pwede natin i-minimize yan. So, if the volume of the solids is greater than the volume of the voids, that is okay. So, ibig sabihin, kung mas mataas yung denominator natin, which is the VS, edi ang makukuha natin na value ng E is less than 1. And if we assume that the volume of the soil solid is equal to the volume of the voids, check natin if that is possible. Mukha namang posible yan dahil nandyan pa rin naman yung voids. So yung mga cases na the volume of the voids is equal to 0 or the volume of the solids is equal to 0, hindi yon mangyayari. Okay? So, para sa VS is equals to VV, so kung titignan natin yung equation, equal yung numerator to the denominator, so the value of E is equal to 1. So, posible na ang maging value ng E natin is exactly 1. But, posible kaya na ang void ratio natin is greater than 1? Kung mangyayari na greater than 1, ibig sabihin lang, mas mataas yung numerator natin, that is the volume of the voids. So, if the volume of the voids is greater than the volume of the soil solids, tingnan muna natin if possible ba nang mangyari yan. So yes, possible pa rin naman na mangyari yan as long as nandito yung dalawang component natin na voids and solids, posibleng mangyari yan. So in this case, the value of E could be greater than 1. Darating tayo dun sa topic na i-discuss natin yung geometric analysis ng maximum possible void ratio sa soil. Pero as of now, we may consider the void ratio can be greater than 1. So yan muna. So pag nakakuha kayo ng value na greater than 1 sa computation mo sa mga problems, huwag kang kabahan dahil possible pa rin naman na mangyari yan. Okay? And that is for our first volumetric ratio, the void ratio. Proceed tayo sa next volumetric ratio, which is the porosity, na i-designate natin siya as N. So, ang porosity is the ratio of the volume of the voids, this time, to the volume of the soil. Kasi yung void ratio natin is volume of the voids to the volume of the soil solids. Sa porosity, volume of the voids to the total volume of the soil. So by expression, that is N is equals to VV all over V. So simple lang din naman to dahil ratio lang ulit ng mga volumes. Pero syempre, tingnan natin kung hanggang saan lang ba yung range ng value para sa porosity. So dahil nga imposible na maging zero ang volume of the voids, so yung una nating assumption is the volume of the voids must not be equal to 0. So therefore, N must not be equal to 0 also. Kaya N must be greater than 0. So yan agad yung una nating makikita ang relation. So parang void ratio rin siya, no? Bawal maging 0 ang value ng N. How about the relation between the volume of the voids to the total volume? So umpisa natin, is it possible na yung total volume of the soil is less than the total volume of the voids? So kung titignan ninyo, yung total volume daw ng lupa ay mas maliit compare sa volume of the voids. Mukhang imposibleng mangyari na mas malaki pa yung voids mo kaysa sa total volume. So mukhang mali. How about if the volume of the voids is equal to the total volume of the soil? So imagine mo na yung total volume ng soil mo is just the voids. Wala man lang solids doon sa ating total volume. So that means both of these relations are not possible sa soil mass. Okay, kaya kung bawal yung ganitong relation between the volumes and the volume of the voids, we can say that N cannot be greater than 1 or equal to 1. Tama ba? Kasi kung V is equals to VV, that is N is equals to 1. Tama ba? Pag dinivide mo yung VV over V na parehas ang value, 1 ang ibibigay. Pero dahil nga imposibleng mangyari yan, N cannot be greater than or equal to 1. So how about if the total volume is greater than the total volume of the voids? That is always the case, tama ba? Lagi naman dapat na mas malaki ang total volume compare sa volume of the voids dahil ang volume of the voids ay component lang ng total volume. So that means yung ibang part ng volume na yan ay para sa volume of the soil solids. Kaya V or the total volume is greater than the total volume of the voids is possible. Kaya we can assume na N must be less than 1. Yun lagi yung makukuha natin kasi imagine mo mas malaki yung denominator natin na total volume compare sa numerator. So ang kalalabasan lang ng value ng N natin is less than 1. So para sa ating summary, N must be greater than 0 but less than 1. So yung value niyan ay somewhere between 0 and 1 or 0 and 100%. Sa pagitan lang ng dalawang yan. Okay? So that is porosity. Pangatlo, meron tayong tinatawag na degree of saturation. So sa degree of saturation, ito naman ay ratio of the volume of water to the volume of the voids. So ito ay parang kumbaga percentage siya ng tubig doon sa loob ng voids. Okay, so ang tawag natin doon ay degree of saturation. So by expression, this is S equals to VW, the volume of the water, over the volume of the voids. So tingnan natin yung posibleng values ng S. Hanggang saan lang ba pwede yung value ng S? So, tingnan natin. Assume muna natin na yung volume of the voids is less than the volume of the water. So, imagine natin na yung volume of the voids is less than the volume of the water. Ito ay imposibleng mangyari dahil dapat ang volume of the voids ay laging mas malaki sa volume of the water since yung volume of water ay component lang naman ng volume of the voids. So, this is not possible. Kaya, kung bawal na mas mababa ang volume of the voids, kung titingnan natin sa equation, mababa yung denominator, edi ang kalalabasan is greater than 1. At dahil nga imposibleng mangyari ito, then S cannot be greater than 1. Hindi pwedeng lumampas sa 100% ang saturation ng lupa. So, posible pala na mangyari yung VV is greater than VW or the volume of the water. So, kung titingnan natin yung equation, mas malaki daw yung VV compare sa VW. So, yung denominator natin is greater than the numerator. So, ang ina-expect nating value ng S is less than 1. At dahil possible naman yan, dahil component lang naman ng voids yung water, so posible or laging mangyayari na yung volume of the voids is greater than the volume of the water. So, that means S is less than 1. So, posible ba na yung volume of water ay equal doon sa volume of the voids? Yes, pwedeng mangyari yan dahil kung sakali man na mangyayari na yung volume of the voids ay equal sa volume of water, ibig sabihin walang volume of the air. At ang tawag natin sa condition ng soil kapag walang air doon sa ating void spaces is the saturated condition. At kung sakali nga na equal itong dalawa, then S is equal to 1 or 100%. So S cannot be greater than 1 but can be equal to 1. So, sabihin, ito na yung maximum value ng S natin. 100% lang. Bawal nang lumampas. So, posible ba na yung volume of water ay 0 doon sa volume ng voids? Yes, possible naman yan. Dahil kung sakaling walang tubig, ang matitira na lang sa volume of the voids is volume of air na lang. So, that means the volume of water is equal to 0 is called the dry condition of the soil. So that means kung dry yan, edi walang saturation. Kung 0 yung volume of the water, titingnan natin doon sa equation, 0 yung numerator, then therefore S is equals to 0. Pwedeng mangyari na S is equals to 0. Unlike doon sa dalawang nauna, dapat lagi lang siyang mas malaki sa 0. Kaya para sa summary nitong saturation, degree of saturation, S could be equal to or greater than 0 but less than or equal to 1. So, yan yung boundary ng degree of saturation. Next, we have the air content. So, ang ating designation is A. This is the ratio of the volume of the air to the volume of the voids. Kanina, sa degree of saturation, yung kinukuha natin is the percentage of water within the voids. Ito namang air content is the percentage of the air within the voids. So, kumbaga, pag sinum up natin yung degree of saturation and yung air content, ang ibibigay niyan ay 100% volume of the voids. Okay? So, by expression, A is equals to VA all over VV. So, syempre, para malaman ulit natin kung hanggang saan lang ulit yung value ng A, mag-assign muna tayo or mag-assume muna tayo ng mga relation between volume of the air and the volume of the voids. So, let's start with this relation. Volume of the voids is less than volume of the air. Same as with the degree of saturation, hindi pwede na yung volume of the voids ay mas mababa sa volume of air or volume of water. Dapat mas malaki lagi ang volume of the voids since component lang naman ang air and water. So, ito ay imposibleng mangyari. So, that means A cannot be greater than 1. Okay? So, how about the volume of the voids greater than volume of the air? So, ito naman, laging mangyayari to na mas malaki lagi yung volume of the voids to the volume of the air. Or, pwedeng equal. Okay? So, para sa case na to, A must be less than 1. So less than 1 lang ang makukuha nating value if the volume of the voids is greater than the volume of the air. So if the volume of the voids is equal to the volume of the air, ang tawag natin sa condition na yun ay dry condition dahil walang volume of water sa volume of the voids. And if that happens, A is equals to 1. Kasi kung titingnan natin yung equation, VA is equals to VV, that is equal to 1. Tama ba? So if VA is equals to 0 naman, so ibig sabihin walang hangin doon sa voids, that means yung voids natin ay puno lang ng tubig, ang tawag natin sa condition na yun ay saturated, therefore A is equals to 0. Kasi sa equation, yung numerator natin ay 0, kaya ang A natin na value ay 0. So pwedeng maging value ng A is exactly equal to 1 or 0 or somewhere between those values, pero bawal nang lumampas or mag-exceed sa 1. Kaya ang value natin for A, boundary natin for A, greater than or equal to 0 but less than or equal to 1. Halos kaparehas lang siya ng degree of saturation. And lastly, para sa huli nating volumetric ratio, ang tawag natin dito is the air-void ratio. That is N sub A. This is the ratio of the volume of the air to the total volume of the soil. So this is, by expression, this is N sub A is equals to VA all over V. So tingnan natin, i-analyze natin yung mga relation na possible between VA, the volume of the air, to the total volume of the soil. So let's start with the total volume is less than the volume of the air. Mukhang imposible na mas malaki pa yung volume ng air mo compare sa total volume ng soil. That is impossible. Also, V or the total volume is equal to the volume of the air. This is also impossible na yung total volume mo is hangin lang. So, nasaan yung soil solid? So, this is impossible. Kaya, yung NA natin cannot be greater than or equal to 1. If the total volume of the soil is greater than the total volume of air in the void spaces, posible yon basta tama naman yung relation natin dahil lagi namang mas malaki yung total volume sa kahit ano pang volume ng mga components natin. So that means if the denominator, the total volume is greater than the numerator, which is the VA, therefore NA is less than 1. So, hindi siya pwedeng maging equal to 1, but less than 1 is pwede. If the VA, or the volume of the air, is equals to 0, nangyari na to sa tawag dito, air content natin, na yung VA is equals to 0, which is the saturated condition of the soil, possible na mangyari yan. So, A is equal to 0. Kung mangyayari man na walang hangin doon sa ating void spaces. Kaya, para sa ating air-void ratio, ang range lang ng value niyan, A must be greater than or equal to 0 but less than 1. Okay? So, yan yung 5 volumetric ratios. So, meron pa tayong mga ratios na gagamitin. So, relation naman ito ng weight and ng mga volumes natin. So, this time, isasama na natin yung weight. So, meron ng involved dito na weight. Kaya balikan muna natin yung ating phase diagram, baguhin natin yung mga dimension. Kasi kanina, yung dimension natin dito is based doon sa volume. Volume ng air, volume ng water, ng solids. So ngayon, baguhin na natin in terms of weight naman. So meron tayo ditong weight of air. So that is W sub A. And then para naman sa water, we have the weight of water. And syempre, para sa solids, we have the weight of the soil solids, W sub S. So, kapag sinum up din natin yung weight ng air doon sa weight of water, syempre, ang ibibigay pa rin yan is the weight of the voids. So, that is W sub V. Ngayon, kung isasum up ko lahat ng mga weights na to, we have the total weight of the voids plus the weight of the soil solids, ang ibibigay niyan syempre is the total weight of the soil. But, so, mayroon lang tayong i-adjust dito sa ating dimensions dahil yung weight ng air is negligible compared doon sa weight ng water and the weight ng solid. So, pwede nating alisin sa system itong weight of air kasi nga negligible naman na yan. Kaya ang matitira na lang sa ating phase diagram is the weight of the water and the weight of the soil solid. So that means yung weight ng void is just weight of water na lang. So para malaman natin yung total weight of the soil, isum up lang natin yung weight of water and the weight of the soil solids. Now, when we say dry weight of the soil, so pwede ko kasi siyang isulat as W sub D. That means the dry weight of the soil. Ito ay mangyayari lang if the weight of the water is equals to 0. Ibig sabihin, dry yung lupa natin. Siyempre, wala nang tubig. So then, kapag nag-dry nga, or let's say the value of the water is equals to 0, then the dry weight is just the weight of the soil solids. So, dahil wala na ngang water, solids na lang yung matitira at ang total weight natin is what we call the dry weight or the weight of the soil solids. Ito ay pwede nating pagpalitin. So, interchangeable yung W sub D sa W sub S. Kasi nga naman, ang dry weight is just the soil solids. But, hindi yan applicable pagdating sa volumes na dahil sinabi natin na yung dry weight is equal to the weight of the soil solids, does not mean na yung dry volume is equal to the volume of the soil solids. So, hindi mangyayari yan dahil pag sinabi nating dry volume, meron pa rin tayong existence na volume ng air, which is not negligible. Okay? Hindi naman natin na-neglect yung volume ng air. Para lang yun sa weight. Weight of air is negligible. So, tandaan niyo lagi yan kasi maraming napagpapalit din yung volume ng soil solids to the dry volume of the soil, which is wrong. Okay, so wait lang tayo. Sa weight lang tayo, pwedeng mag-interchange ng dry weight to the solids or the weight of the soil solids. So, yan yung gagamitin ng phase diagram dahil yung susunod nating mga ratio ay relation na to ng weights and ng volumes. So, umpisahan natin sa tinatawag natin na moisture content. So, ang moisture content natin is, ang designation nito is W. This is the ratio of the weight or mass of the water to the weight or mass of the soil solid. So, pwede kang gumamit ng weight na unit or pwedeng naka-mass yung gagamitin mo. Okay lang yan dahil magka-cancel out din naman yung unit niyan. So, percentage or decimals lang ang expression ng ating moisture content. So, dito wala na tayong kukuning range of values dahil kung mapapansin ninyo, pwedeng tumaas yung value niya dahil pwedeng mas mataas yung water kaysa sa solids, mas mataas yung solids kaysa sa water. So, wala tayong range kapag weight and volume relationship na yung pinag-uusapan natin. Okay? So, pangalawa, meron tayong tinatawag na bulk or mass or total or wet or moist unit weight of the soil. So, kahit anong term dyan yung ibigay, isa lang yung ibig sabihin yan. That is gamma. So, yun yung designation natin. So, to calculate gamma, actually, makikita mo na yun sa definition. Sinabi na total unit weight. That means, ang computation natin dito is, this is the ratio of the total weight of the soil sample to the total volume of the soil. So, that is, by expression, gamma is equals to weight all over volume. Or, pwede mo rin namang gamitin yung term na density. Wala namang problema doon kung gusto mong tawagin siya na bulk density, mass density, total, wet, moist density. Okay lang. Huwag lang kayong malilito. So, dito sa density natin, that is mass. The total mass of the soil sample all over the total volume of the soil sample. So, that is the density. So, yun yung pangalawa nating weight-volume relationship. Pangatlo, is this time wala nang water, ano? Ang tawag natin dito is the dry unit weight. Kasi yung sa number 2, pag sinabing moist, hindi ibig sabihin ay saturated. Pag sinabing moist, partially saturated siya. So, meron pa ring air, meron pa ring water doon sa volume of the voids. Pero pag sinabi nating dry unit weight, that is gamma D. So, ito, syempre, alam natin na wala ng weight of water. Kaya yung total weight natin, which is, pwede natin tawagin as the dry weight, that is equal to the weight of the soil solids alone, since negligible nga ang weight ng air. So, dry unit weight is the ratio of the weight of the soil to the total volume of the soil in dry condition. So, So, parang bulk unit weight din to, no? Yung number 2, yun nga lang, meron siyang sinabi dito in specify na condition, na dry condition. Kasi nga naman, kung titingnan mo, total weight all over the total volume is the same as the bulk unit weight. Tama ba? Yun din yung sa number 2 natin, yun yung formula. Kasi kung titingnan mo yung total weight natin, which is purely solids lang yan kapag dry condition, edi therefore yung dry unit weight, pwede na natin itong sabihin as the bulk unit weight. Yun nga lang kasi ginagamit natin yung term na bulk unit weight or yung number 2, yung mga terms na nakaspecify doon, kapag moist. Kaya nga siya binigyan ng sariling terminologies para ma-identify agad natin yung condition ng soil. So, we have the dry unit weight by definition or by expression. This is gamma D is equals to the dry weight all over the total volume of the soil. So, pwede mong gamitin yung sa dry weight, yung weight of the soil solids. So, walang problema yan. Or pwede kang gumamit in terms of mass. So, meron kang tinatawag na dry density. So, yan yung number 3 natin. So, kung pwede pala na magkaroon tayo ng dry unit weight, posible na magkaroon tayo ng saturated unit weight. So, para sa saturated unit weight, so, alam na natin yan na walang air doon sa ating soil sample. So, ang designation natin para sa saturated unit weight ay gamma sat. So, this is the ratio of the weight of the soil to the total volume of the soil. So, parehas pa rin siya ng definition sa bulk density, but this time, meron siyang nakalagay na condition in saturated condition. So, by definition or expression, gamma sat is equals to the saturated weight, which is the total weight din naman, all over the total volume of the soil, or pwede ka ulit gumamit in terms of mass, that is the saturated density. So, yan yung pang-apat. Posible rin na magkaroon tayo ng isa pang condition wherein yung soil sample natin is submerged sa tubig. So, ang tawag natin dito is submerged or buoyant effective unit weight. So, ang designation natin sa kanya is gamma prime. So, ang formula natin dito or ang ratio natin dito is the ratio of the submerged weight of the soil solids to the total volume of the soil. So, that is gamma prime is equals to the submerged weight of the soil solids all over the total volume. So, tandaan niyo submerged weight of the soil solids, not the entire soil. Next, we have the unit weight of the soil solids. So, para lang to sa mga soil solids. So, ang definition natin dito is the ratio of the weight of the soil solids to the volume of the soil solids. So, that is gamma S is equals to WS all over VS. O pwede ka rin namang gumamit ulit ng density. So, walang problema yan. So, para sa number 7, halos magkakamukha lang naman yung formula natin ng unit weight kasi ang general formula naman yan is weight over volume. Nagbabago lang naman siya depende sa condition ng soil natin. So, para sa number 7, so meron naman tayong tinatawag na bulk or mass specific gravity na ito. So, ang designation lang natin dito ay G. So, ang definition, this is the ratio of the bulk unit weight, kaya nga siya tinawag na bulk specific gravity to the unit weight of the water. So, remember sa inyong fluid mechanics na para makuha natin yung specific gravity ng isang object, kailangan mo ng density or unit weight ng object na yon at dinidivide natin siya sa reference na ginagamit natin, which is the density or the unit weight of water. So, ganun din naman dito sa ating soil mechanics dahil ang pagkuha natin ng G, that is the gamma, which is the bulk unit weight divided by sa reference natin na water. That is the unit weight of water. So, pwede ka rin ulit gumamit ng density as long as gagamitin mong value para sa water ay density lang din. Dapat parehas sila ng unit dahil dimensionless ang specific gravity. So, during the course, so ang gagamitin nating value ng unit weight of water is 9.81 kN per cubic meter at ang density ng water natin is 1 gram per cc unless otherwise mag-specify ako ng ibang value. Pero by default, ito yung mga gagamitin nating value ng unit weight and density of water. Okay? So, para sa last weight-volume relationship natin, meron tayong tinatawag na specific gravity of the soil solids. So, solids lang ang pinag-uusapan. So, this is the ratio of the unit weight of the soil solids to the unit weight of the water. So, same formula, medyo nagbago lang dahil kung gusto mong malaman yung specific gravity ng soil solids, then kailangan mo ng unit weight or density of the soil solids. I-divide mo na lang siya sa reference natin na water. So, ito yung formula para sa specific gravity of the soil solids. So, pwede ka rin gumamit ulit ng density. So, yun lang lahat ng mga ratios na gagamitin natin para makapag-establish tayo ng mga special formula or mga derived formula na mas mabilis na. Kumbaga, pag ginamit natin is mas mabilis na siya na makakapag-solve ng mga parameters sa soil. Okay? Okay, so now na meron na tayong idea about doon sa mga basic ratios, it's time na para mag-derive ng mga formula or relationship between those ratios. Kailangan nating i-simplify yung mga equation or kumuha ng mga relationship dahil kung gagamitin natin yung mismong mga ratios na yon, yung volumetric ratios especially, mukhang mahihirapan pa tayo dahil mahirap nga namang mag-solve ng volume ng air doon sa lupa, volume ng water, ng volume ng solids, although may mga laboratory experiments, pero I think it would be better kung ma-eliminate na natin yung mga volumes na yan o yung mga weights and mag-come up tayo doon sa isang equation na ang involved na lang ay yung mga mismong properties of soil. Okay? So, yan yung una natin gagawin. So, para sa relationship between the void ratio and porosity. So, according dun sa mga ratios na binigay natin, that the void ratio is the ratio between the volume of the voids to the volume of the solids, and the porosity is the volume of the voids to the total volume of the sample. So, ito yung gagawin natin. So, our goal is to eliminate these volumes at kailangan ang matira na lang is yung mga parameter natin na void ratio and porosity. Para at least hindi na tayo kailangan pang mag-solve ng mga volumes to come up with the void ratio or porosity. So, let's start with the void ratio. So, actually, pwede ka naman mag-start ng porosity. Walang problema dahil parehas lang din naman na ang ibibigay sa yung formula. So, ngayon, ang goal natin is maipasok natin yung ratio para sa porosity. So, to do that, kung titingnan natin yung formula ng porosity, pwede natin isolve yung volume of the voids. Tama ba? At once na ma-solve natin yan from the porosity, pwede natin ngayon i-substitute sa equation ng void ratio. So, by doing so, meron tayo ngayon makikita. Ayan, makikita niyo sa ating animation. And from this point, ay hindi na natin kaya pang i-simplify ito. Kasi wala na tayong ibang pwedeng ilagay na equation para ma-eliminate yung mga volumes. Tama ba? So, mayroon pa tayong total volume at saka volume of the soil solid. So, hindi pa tayo tapos. Kasi ang goal natin, ma-eliminate sila. Kaya, maglagay tayo ng mga basic equation na diniscuss ko doon sa phase diagram. So, itong total volume natin, pwede ko siyang palitan as the volume of the soil solids plus the volume of the voids. Tama ba? Na-discuss natin tong formula na to doon sa phase diagram pa lang. So, pwede kong palitan yung total volume. And then, once na mapalitan ko na yan, pwede ko nang i-simplify. So, volume of the solids divided by the volume of the solids is 1. And volume of the voids all over the volume of the solids yung matitirang term doon. But, volume of the voids all over the volume of the soil solid is actually the void ratio. So, pwede ko na pala itong eliminate yung mga volumes na yan dahil pwede ko siyang palitan ng void ratio. So, ayan. So, meron na ngayon tayong nakuha or na-derive na equation between the porosity and the void ratio. So, simplify na lang natin. So, if you want to solve for n, so n is equals to E all over 1 plus E. Ngayon, kung gusto mong i-solve yung E in terms of n, so pwede mo namang rearrange yung equation and solve for E. So, E is equal to N all over 1 minus N. So, ito ngayon yung relationship between the void ratio and porosity. So, pwede nyo nang ilista yan sa mga formula na dahil magagamit natin to sa mga susunod nating mga topic. Hanggang sa foundation engineering, magagamit nyo pa rin itong mga relationship na ito. Okay, so next, kuha na natin ng relationship between the degree of saturation, porosity, the moisture content, and the specific gravity of the soil solids. So, inilista ko na yung mga basic ratios na yan. So, para sa degree of saturation, sa porosity, moisture content, and the specific gravity of the soil solids. Ngayon, kung makapansin nyo sa specific gravity of the soil solids natin, meron tayong gamma S. So, kaya isinama ko na rin yung formula natin for gamma S, which is the weight of the soil solids to the volume of the soil solids. And meron tayong gamma of water or the unit weight of water, which is that is the ratio between the weight of the water to the volume of the water. Isinama ko na dahil maaaring magamit ko ito para ma-simplify natin yung relationship ng apat na parameters na to or na properties na to. So, pwede kayo mag-start kahit saan sa mga basic ratios na yan. Pero ako, mag-start ako doon sa degree of saturation. That is the volume of the water all over the volume of the voids. So, isa-isahin mo lang na ipasok yung iba pa nating ratios. So, dahil meron tayo ditong volume of water, kung titingnan natin sa list of equations sa taas, ang meron lang na volume of water doon sa equation ay yung unit weight of water. Tama ba? So, therefore, isolve natin yung volume of water from the unit weight of water and isubstitute natin doon sa equation of the degree of saturation. And then, simplify natin yung kalalabasan. So, next, tingnan natin, meron pa tayo ditong volume of the voids. So, kung titingnan natin yung mga list of equations sa taas, ang meron lang dito na volume of the void sa equation ay yung void ratio. So, pwede kong isolve yung volume of the voids from the void ratio. So, pwede nating isubstitute na lang yung value na yan or yung expression na yan dun sa ating equation. And how about the weight of water? So, pwede nating ipasok. Bawal ko nang gamitin yung unit weight of water dahil naipasok ko na yan dun sa equation dahil magka-cancel out lang yan at babalik tayo sa dati. So, ang gamitin na ngayon natin is yung equation na natira na involve pa rin yung weight of water and that is the moisture content. So, kung isi-simplify natin yung moisture content and solve for the weight of water and isa-substitute natin siya doon sa ating equation, but hindi pa rin tayo tapos dahil nandito pa rin yung weight and volume. Ang goal natin is ma-eliminate yung mga yan. So, tingnan natin yung natirang equation sa taas. So, kung mapansin ninyo, yung weight of solids over the volume of the soil solids sa equation natin ng degree of saturation, itong na-simplify na natin, is actually the unit weight of the soil solids. Tama ba? So, pwede ko palang palitan na lang yan ng gamma S. So, ayan. But, gamma S over gamma of water is actually the specific gravity of the soil solids. Kaya, ito, alisin ko na rin at palitan ko na lang siya ng specific gravity of the soil solids so that the relation between these four parameters or properties, degree of saturation, porosity, moisture content, and specific gravity of the soil solids can be expressed as SE is equals to WGS or ang basang nga nila dyan is the sewages. So, ayan, pangatlo sa mga formula na na-derive na natin using the basic ratio. So, ilista nyo na rin yan so that at the end of the video, meron na kayong list of the formula na magagamit natin pagdating naman sa problem solving. Okay, so next, i-derive naman natin yung iba pang equation ng bulk unit weight. So, since we define the bulk unit weight as the ratio between the total weight and the total volume, so mag-start tayo sa formula na yan. And then, palitan na lang natin yung mga variables natin dito like weight and volume para ma-eliminate sila. So, pwede kong palitan yung total weight ng sum of the solids, the weight of the soil solids, and the weight of the water. So, by doing so, ito yung mangyayari. Kaso nga lang, hindi natin na-eliminate. Nadagdagan pa nga tayo ng mga weights. Okay lang yan dahil meron naman tayong formula ng moisture content which is equal to the weight of the water to the weight of the soil solids. So, pwede kong palitan yung isa sa mga variable natin dito. So, pwedeng palitan mo yung W sub S in terms of the moisture content or yung isa, yung weight of water in terms of the moisture content. Huwag yung dalawa, isa-isa lang. So, gawin natin, i-solve natin yung weight of water. at i-substitute natin doon sa equation. So dito pwede ko namang i-factor out na lang yung weight of the soil solids since both terms sa numerator ay containing weight of the soil solids. So matitira is we have the 1 plus the moisture content multiply by the weight of the soil solids. So balikan natin ito mamaya kasi maraming way para ma-derive yung equation natin for gamma. Maraming formula for gamma. So ang gawin natin next is gamitin natin yung formula ng dry unit weight since the dry unit weight is the ratio between the weight of the soil solids to the weight to the total volume of the soil. So mapapansin natin na nasa equation na yung Ws over V. Tama ba? Kaya pwede ko na lang substitute yan or eliminate yan at palitan ko na lang ng gamma D. So ito yung una nating equation sa bulk unit weight. Meron pa tayong ibang equation. So balikan natin yung isang form kanina ng unit weight. Balik tayo dito sa part na to. Kasi kanina, ginawa natin is yung Ws over V ay ginawa nating dry unit weight. So ngayon, ibahin natin yung approach. So palitan natin ng GS or ipasok natin yung specific gravity of the soil solid. Kaso paano maipapasok yan? Wala namang common between the two equation. So remember that unit weight of the soil solid is weight of the soil solid all over the volume of the soil solid. So, pwede kong pagsamahin itong GS and gamma S since common naman sa kanila yung gamma S. So, pwede kong i-combine yung dalawa. And then, from this equation, pwede kong isolve yung weight of the soil solid at maisa-substitute ko na siya doon sa ating equation. So, palitan natin. We have this equation now. So, ang natira na lang, na-eliminate na natin yung mga weight. Pero, may problema pa dahil nandyan pa yung mga volume. So, yun yung goal natin, ma-eliminate yung mga volume. So, ano kaya yung pwedeng maging way para ma-eliminate yan? So, i-assume natin or palitan natin yung volume ng solids. So, kung i-imagine nyo yung black diagram or phase diagram natin to calculate the volume of the soil solids, that is the total volume less mo yung volume of the void. So, ang matitira na lang is the volume of the soil solids. Tama? Kaya, pwede kong palitan yan ng V minus VV. And then, isimplify na lang natin yung equation. So, yung mga volume, ihiwalay natin at isimplify. So, meron tayo ditong V minus VV all over V. So, kapag sinimplify mo yan, that is actually 1 minus VV over V. Okay? So, yung VV over V, kung familiar kayo dito, tama ba na ito ay porosity? So, porosity is the ratio between the volume of the voids to the total volume of the sample. Kaya, pwede ko nang ma-eliminate yung mga volumes na yan, pero ipapalit ko yung porosity. So, that is N. So, this is the second formula para sa bulk unit weight. Pwede mo rin itong gamitin. Depende kasi ang formula na gagamitin mo sa given. Kung ang given ay may moisture content or porosity, edi gamitin mo itong formula na to. Kung given naman is dry unit weight and the moisture content, gamitin mo yung formula na derive natin kanina. So, ayan yung pangalawang equation. Actually, meron pa yung ibang equation. Iba naman yung naging approach ng kanyang derivation. So, balikan natin yung part na nandito tayo. So, gusto nating i-eliminate yung Vs at saka yung total volume. So, ang ginawa natin kanina is pinalitan natin yung Vs ng V minus VV. So, pwedeng hindi yun yung gawin mong approach. Pwedeng ang palitan natin is yung volume sa ilalim. Ang volume naman, ang total volume naman is the sum of the solids, the volume of the soil solids, and the volume of the void. So, pwedeng yan yung palitan ko. At saka, isimplify natin yung equation. So, pwede kong i-divide yung numerator and the denominator by Vs. So, yung numerator maka-cancel out yung Vs. Tapos, sa denominator, madi-divide yan sa Vs. Ayan, pwede mo nang i-simplify yung denominator. So, that is 1 plus Vv over Vs. But, Vv over Vs is actually the void ratio. That is the ratio between the voids, the volume of the voids to the volume of the soil solid. Kaya pwede ko itong i-eliminate at palitan na lang ng void ratio. So, ito yung pangatlong equation natin. This time, walang porosity doon sa mismong equation, but nandito naman yung void ratio. So, yan yung pangatlong equation ng bulk unit weight. And meron pang isa na formula ang bulk unit weight. So, balikan ulit natin yung isa pang form nito kung saan nandito tayo. Babalik tayo sa original na form. Babaguhin lang natin yung mga substitution na gagawin natin. So, from the total weight all over the total volume, babaguhin lang natin yung total weight as the weight of the soil solid plus the weight of the water. Pero, hindi tayo gagamit ng moisture content. Kasi yung ginawa natin kanina, ipapasok na natin dito yung unit weight of water. Kasi nga, mayroon tayo sa equation na weight of water. At dahil meron tayong weight of the soil solid, kailangan natin gamitin yung specific gravity of the soil solids. So, isolve lang natin yung weight of water and weight of the soil solid from the unit weight of water and the specific gravity of the soil solid respectively. At yan ay isa-substitute natin dito ngayon sa equation. So, ayan. So, since factorable naman yung unit weight of water, edi i-factor out na natin siya sa system or sa ating equation. So, ang matitira na lang dito ay mga volumes na eliminate na natin yung mga weights. So, ang gawin natin is palitan natin yung total volume ng volume of the voids plus the volume of the soil solids. So, ngayon, ang gawin na lang natin is i-divide natin all terms sa numerator and sa denominator by the volume of the voids. So, okay lang yan kung i-divide mo both numerator and denominator kasi man-neutralize naman yan. Basta wag lang yung numerator lang or denominator lang. So, dito ang mangyayari is volume of the soil solids all over the volume of the voids is actually the reciprocal of the void ratio. Tama ba? Kasi ang void ratio is VV over VS. Kaso baliktad ito, nagkaroon tayo ng VS over VV. So, that means reciprocal lang natin yan. So, itong part na to, ayan, tsaka yung dito sa baba, ito ay magiging 1 over E. Yung VV over V, gawin natin siyang 1. Okay? So, ayan. And how about the volume of water all over the volume of the voids? Meron ba itong equivalent? Yes, meron yung equivalent. That is the degree of saturation. Kaya pwede ko itong palitan na lang ng degree of saturation. And kung makikita ninyo na eliminate na natin yung mga volumes. At ang natira na lang, syempre, yung mga properties ng soil. So, simplify na lang natin yung numerator and also the denominator. And ayusin natin yung buong equation for the bulk unit weight. At magka-come up tayo dito. GS plus SE all over 1 plus E times the unit weight of water. So, ito yung ika-apat natin na formula ng bulk unit weight. Actually, marami ka pang makikita kung sakali man natitingin ka ng mga textbooks. So, marami pa rin namang unit weight formula. So, nakadepende na lang kasi yan sa paano mo i-derive yung equation. So, kung meron kang nakitang bagong equation ng bulk unit weight, pwede kang mag-practice ng derivation using the basic ratios tulad ng ginagawa natin ngayon. Okay? So, ito yung summarized. Yan yung mga list of formula na dinerive natin para sa bulk unit weight. Okay? So, next, proceed tayo sa dry unit weight. So, ang dry unit weight naman is, siyempre, ito naman yung basic ratio natin, the weight of the soil solids or the dry weight of the soil all over the total volume of the soil. So, ngayon, ang gawin nating approach is palitan natin, siyempre, yung weight of the soil solids using the specific gravity of the soil solid. Ito yung ginawa natin kanina pa, nakasimplify na. So, substitution na lang yung gagawin natin. And ayan, so ang natira na lang is volumes, VS and V. So, palitan natin yung total volume sa denominator ng volume of the solids plus volume of the voids. And then, i-divide natin both the numerator and the denominator by the volume of the soil solids. So, yung VS natin sa numerator is ma-eliminate na yan. Pero yung denominator natin is ma-divide pa ng VS. And then, i-simplify na natin yung denominator. So, meron tayo ditong 1 plus E. Kaya, ang formula natin for the dry unit weight is GS gamma water all over 1 plus E. So, kung titingnan mo, halos kamukha lang din naman siya ng bulk unit weight natin, di ba? So, kung babalikan natin yung formula na na-derive natin kanina, sa bulk unit weight, that is gamma is equals to GS plus SE all over 1 plus E gamma of water. Ang kinaiba lang nito, ng dry unit weight natin is yung term na SE. ay wala. Tama ba? Bakit kaya? So, dahil ang bulk unit weight, sabi ko rin naman sa inyo kanina na dry unit weight is also a bulk unit weight kasi ang definition natin is total weight all over the total volume. Yun nga lang, sa dry unit weight, yung total weight natin ay weight of the soil solids lang or yung dry weight lang mismo. So, parang nanggaling lang din naman siya sa bulk unit weight. Binago lang natin yung condition ng soil. So, para sa dry condition of soil, alam natin na yung saturation niyan ay 0. Tama ba? So, if the S or the saturation is 0, then the bulk unit weight is actually the dry unit weight. So, by substitution, nung mga condition natin doon sa bulk unit weight, if S is equals to 0, itong term na to, yung SE na yan, mawawala na yan, at masisimplify yung equation natin to, ayan, ito yung na-derive natin. So, parang nanggaling lang din naman pala siya sa bulk unit weight with the adjustment of the different condition of the soil. So, isa lang ang formula natin sa dry unit weight. Okay? So, next, punta tayo sa saturated unit weight. So, this is the ratio between the saturated weight of the soil all over the total volume of the soil. So palitan na natin yung saturated weight and the total volume. So, that is, para sa ating saturated weight, syempre pag sinabi naman saturated weight, that is the weight of the solids plus the weight of the water. Total unit weight, total weight pa rin ito, kaya pwede mo pa rin siya i-consider as bulk unit weight. And para naman sa ating total volume, syempre yan pa rin naman, the volume of the soil solids plus the volume of the water. Hindi na natin isasama dito yung volume of air kasi ito ay nasa saturated condition. Walang volume of air. Kaya yan lang yung total volume natin. So, next, syempre, palitan natin yung ibang mga terms dyan gamit yung ibang ratio natin. So, para sa WS, palitan natin siya ng formula galing sa specific gravity of the soil solid at yung weight of water, palitan natin galing doon sa formula ng unit weight of water. Para ang matitira na lang is volumes na gusto nating ma-eliminate. So, since factorable naman yung unit weight of water, so i-factor out muna natin. And under the saturated condition, so isama na natin yung mga condition kasi saturated naman ito para mas madali nating ma-simplify yung equation. So, alam natin na at saturated condition, the total volume of the voids is the same as the volume of the water. Kasi nga, wala namang air kapag saturated. Kaya yung mga volume of water natin sa equation ng gamma sat, pwede natin munang palitan as the total volume of the voids. So, palitan natin, and then i-divide natin all terms sa numerator and sa denominator ng volume of the soil solids. So, by doing so, yung mga VS over VS, 1 na lang yan. So, palitan natin ng 1. At yung VV over VS na mga terms, that is the void ratio. Tama ba? So, pwede ko na lang ding palitan ng void ratio yan. So, magsisimplify yung equation natin to GS plus E all over 1 plus E times the unit weight of water. So, balikan ulit natin yung bulk unit weight na diniscuss natin kanina. So, ito yung bulk unit weight. Kaso nga lang, under saturated condition, ang mga condition natin dito is S is equals to 100% or 1 kapag saturated condition yung soil. So, pwede kong palitan or i-substitute ito doon sa ating formula sa bulk unit weight, yung S is equals to 1, at yung gamma natin dahil nga naging saturated na siya, gamma sat na. So, babalik ka pa rin doon sa na-derive natin kanina lang na formula. So, ibig sabihin pala, yung dry and saturated unit weight ay pwede mong ma-derive using the bulk unit weight, pero kailangan mong i-incorporate yung kanilang condition. Kung sa dry or saturated condition ba yung soil natin. Okay? So, yan yung formula for the saturated unit weight. So, marami-rami na tayong formula. So, kailangan nyo nang i-summarize lahat. So, last, meron pa tayong i-discuss na isa pang formula, which is the effective unit weight. So, ito ay iba ang approach dahil ang mangyayari dito is isa-submerge natin yung mismong soil solids or yung buong lupa natin dahil yung tubig naman ng part ng soil natin is sasama lang din naman siya doon sa tubig kung saan natin sinubmerge yung soil sample natin. So, para sa unit weight, effective unit weight, ang formula natin is the submerged weight of the soil solids, tandaan natin yan, all over the total volume. So, para ma-imagine natin yung magiging numerator natin dito na W sub S submerged, tingnan muna natin yung illustration. So, we know na sa phase diagram, kung isasubmerge mo ang lupa, then therefore, siya ay magiging saturated. Tama ba? Saturated yan, submerged na yan eh. So, ang dalawa na lang component natin, we have the water and the soil solids. Ngayon, kung kukunin natin yung weight ng soil solids, that is W sub S, tama ba? Kapag mineasure natin yung weight niyan in air, that is W sub S. Pero, kapag yan ay na-submerge, merong force na mag-counteract dito sa weight of the soil solids natin. Dahil sinubmerge mo yan, magkakaroon tayo ng tinatawag na buoyant force. If the buoyant force is greater than the weight of the soil solids, ibig sabihin yung soil solids natin ay magfo-float doon sa tubig. If the buoyant force is less than the weight of the soil solids, ang tendency ng soil solids natin ay mag-settle pababa. Samantalang if the weight of the soil solid is equal to the buoyant force, so masususpend lang yung soil solids natin somewhere doon sa depth ng tubig. Pero, dahil obvious naman na mas malaki ang density ng solids compare sa water, ang tendency talaga ng solids natin is mag-settle sa ilalim. So, bababa ng bababa yan. So, meron tayong unbalanced force. Pero, bago natin pag-usapan yung unbalanced force na yan, paano ba natin kukumputin yung buoyant force? Paano ba natin nasusolve sa fluid mechanics? Paano ba natin sinusolve yung buoyant force? Tama ba na to calculate the buoyant force, that is just the product of the unit weight of the fluid na kung saan natin sinubmerge yung object, and dito naman ang case natin is water lang. So that is the unit weight of water and the volume displaced by the object. So, yung object natin dito is the solids. So, therefore, yung volume displaced by the solids is actually the volume of the soil solids. Kaya, yung buoyant force natin, that is the product between the unit weight of water and the volume of the soil solids. Kaso nga lang, dahil sabi nga natin kanina, dahil mas malaki yung density ng solids compare sa water, ang tendency nito ay bumaba lang ng bumaba yung mga soil solids natin. So, ibig sabihin, kapag sinama up natin tong mga forces na to, is mag-govern pa rin yung downward force. So, ito yung tinatawag natin na submerged weight of the soil solids. So, kumbaga, pag mineasure mo yung weight ng solids natin underwater, ito yung makukuha nating value. So, paano natin makukuha yung value ng W sub S submerged? That is just the difference between the weight of the soil solids in air and the buoyant force. So that is W sub S minus yung buoyant force natin, which is expressed as the product between the unit weight of water and the volume of the soil solids. So yan yung computation para sa submerged weight of the soil solids. Kailangan natin yan dahil sa derivation, yan na yung ipapalit natin dun sa equation. Okay? So, naintindihan na natin kung bakit ito na yung gagamitin ko sa derivation. So, balikan na natin tong equation. So, yung Ws and Vs, kailangan nating ma-eliminate yan eh. Tama ba? Tapos mag-come up tayo ng equation. So, ang una natin gawin, maraming way din para ma-derive mo yung equation ng gamma prime. So, umpisahan muna natin sa isang way kung paano natin ma-eliminate yung mga weights and volume. So, palitan natin yung denominator na total volume ng, syempre, sanay na kayo dyan, that is just the volume of the soil solids plus the volume of the voids. So, from that, edi palitan na natin ngayon yung numerator. Yung, mag-start muna tayo sa weight of the soil solids. So, gamit pa rin yung specific gravity of the soil solids. Pwede kong i-substitute yan dun sa ating equation. Ayan. At kung mapapansin mo, factorable naman sa numerator yung unit weight of water. Also, the volume of the soil solid. So, i-factor out natin yan sa ating equation. At volume na lang ang matitira. So, i-divide natin both the numerator and the denominator by Vs. So, divide natin all terms by Vs. So, yung Vs over Vs, 1 na lang yan. At yung Vv over Vs, doon sa denominator is the void ratio. Kaya, pwede ko na lang yung palitan ng void ratio. So, ang equation natin, isang equation natin sa effective unit weight is Gs minus 1 all over 1 plus E times the unit weight of water. So, yan yung una. So, balikan natin yung isa pang form kanina. Ayan, balik tayo dito. So, palitan naman ngayon natin yung weight of the soil solids. Tama ba na para makuha natin yung weight of the soil solid, that is just the total weight minus the weight of water. Tama. So, pwede ko siyang palitan ng ganong expression. So, ngayon, palitan natin ngayon yung weight of water using the formula of the unit weight of water. So, that is just unit weight of water times the volume of water. So, ipapasok ko lang siya sa equation. At yung last two terms natin, itong dalawa. Dahil parehas naman silang may unit weight of water, edi i-factor out natin. Factor out natin yung negative and yung unit weight of water. So, magkakaroon tayo ng, ayan, simplified form. So, volumes na lang matitira kasi may weight pa tayo ditong isa. So, pag hiwalayin natin, i-separate natin itong dalawang terms na to. Ayan. So, meron tayong weight over volume sa unang term minus itong expression natin dito sa pangalawang term. So, palitan natin doon sa second term, yung total volume. Babayaan na muna natin itong weight over volume kasi mukha namang meron na itong equivalent na expression eh. So, doon muna tayo sa kabilang side. So, yung total volume natin, pwede kong palitan as the volume of the voids plus the volume of the soil solids. So, dahil yung soil natin ay submerged yan, tama ba? At submerged condition, alam naman natin na yung soil becomes fully saturated. Kaya yung total weight natin is actually the saturated weight of the soil. At yung volume of the voids natin is only the volume of water. Kasi nga ito ay saturated condition. So, palitan natin yung mga variables na yan para maipasok natin yung submerged condition, which is also saturated condition of the soil. So, palitan ko yung weight, total weight ng saturated weight, at yung volume of the voids, palitan ko ng volume of the water or vice versa. So, ayan. So, ngayon, dahil na ipasok na natin yung condition na submerged and saturated, simplify na natin yung equation. So, yung first term, kung titingnan mo yung first term, this is actually the saturated unit weight. Tama ba? The saturated weight all over the total volume is the saturated unit weight. Tapos sa second term, pwede kong i-cancel out yung VW plus VS dahil both ay meron sa numerator and the denominator. So, maka-cancel out na yan. Ang matitira na lang ay unit weight. Kaya, i-simplify natin yung nakuha nating equation. So, this is just gamma sat minus gamma water. This is the second equation para sa effective unit weight. Kaya meron tayong dalawang equation. So, ito yung una at ito yung pangalawa. Ito yung kanina nating dinerive. So, kung papansin ninyo yung gamma sat, tama ba na-derive na natin ito kanina sa saturated unit weight na ito ay equivalent din sa GS plus E over 1 plus E times the unit weight of water. Yan. Actually, tama yan. Kasi pwede mong i-substitute yan, yung equation na na-derive natin kanina, dito sa nakuha nating equation para sa effective unit weight. And then, kapag sinimplify mo yan, ang kalalabasan mo ay itong isa pang equation. So, parehas lang pala talaga yung nakukuha nating equation. Iba-iba lang yung forms nila. Okay? So, para dito sa baba, ay ang GS minus 1 all over 1 plus E, ang tawag natin dito is the critical hydraulic gradient. So, ito ang magdidictate kung yung soil mo is under na siya ng tinatawag na boiling condition or alive condition or yung mas kilala sa tawag na quicksand condition. Na kung saan, yung lupa natin ay hindi na kayang mag-support ng load. Na kung saan, kapag nag-apply ka ng load doon sa lupa na yan, is ang tendency is bababa lang ng bababa yung load na in-apply natin kasi hindi niya na kayang suportahan. So, ang tawag nga doon sa Tagalog is kumunoy, tama ba? Or quicksand nga sa English. So, ayan. So, itong mga formula na to ay ilan lang. So, actually, marami namang derived formulas sa geotechnical engineering. So, kung gusto mong i-derive using the basic ratios, so, ayan, tinuruan ko na kayo kung paano, pwede na kayong makapag-practice. So, ito lang ay iilan lang naman sa mga formula at hindi ko na i-derive lahat ng equations. Okay? So, I hope na naintindihan ninyo yung mga formula kung bakit naging ganyan, saan nanggaling at paano sila magagamit. So, pwede na rin kayong mag-practice ng derivation ng ibang yung formula na makikita sa mga textbook kung mag-aaral kayo. Okay? So, yung next video natin is problem solving. So, ito naman yung application ng mga formula na dinerive natin dito sa pwedeng field or laboratory experiments para at least ma-appreciate ninyo yung gamit ng mga formula na to. Okay? So, I hope to see you again doon sa ating second video which is the problem solving. Okay? So, thank you for listening.